All right, moving on in our review, I want to take a look at this next example here in problem 3. And in problem 3, we're going to analyze a graph of a function. So we're given a function graph over here to decide, and it asks us to go through and analyze its characteristics. So we're going to introduce a couple topics that we talked about back in Module 4 when we were talking about the behavior of a graph with the increasing, decreasing, constant intervals, relative extrema, turning points in your graph, minimaxes. Right? And of course, always domain and range, and some other information that we can gather from the graph so we can help characterize it, right? Give us behavior, get a good visual for someone about this graph. So as we look at this example, it asks us to find the domain of g of x. So we got this function g of x graphed over here to decide, which domain, of course, are all the x values, right? So that's where our graph takes place on the x-axis. So, I mean, we could shade in where we see our graph right here in black, right? As we go from negative infinity to positive infinity, right? There's no breaks in this graph. This is a continuous function, right? All real numbers make our domain. So our domain, as we write all real numbers x, we write that using an interval. So using interval notation, negative infinity to infinity, right, would be the domain. So again, this graph covers the entire x-axis. There's no undefined value for this function. There's no break in the graph. Now as we look at the range, right, range are of course a list of all the y values that make up this function graph. So if I'm looking at it, right, with our graph in front of us, we want to look at the y-axis. So where's your graph go? Right, how far down does it go? Well, it goes down forever to negative infinity, right? And of course, it climbs up to positive infinity. If you look at the left and right tails of this graph, right, the left and right tails go opposite directions. One's going up to infinity, and the other's going down to negative infinity, and all in between. So as far as range goes, our range is also all real numbers. So listing that in interval notation, all real number values of y, negative infinity to infinity. And it covers the entire y-axis. So each x, right, gives you an output of y, gives you exactly one output, and it's defined for all real numbers x. So again, talking about domain and range. Moving on, let's go look at this set of x values where the function g of x is increasing. So where is this graph rising or going up from left to right? That's what we're looking for. So as I read my graph here, I want you to look down here at negative 2. At negative 2, our graph is increasing, right? It's going up. It's rising from left to right. So as far as a increasing interval, it looks like we're looking between, what? Negative 2 and 1 on the x-axis. So all x values greater than negative 2. So I'm going to put it in interval notation. So let's write that down here. Our increasing interval. This graph has 1, and that's all x values greater than negative 2 and less than 1. So yeah, between negative 2, right, and 1 on the x-axis, the graph is rising. It's going up from left to right. Now, as you look at your graph, as far as moving left to right, you see this first area, right? I'll highlight it here in yellow. You see this graph decreasing, so that's what it asked me for in my next part. Find the x values where the function is decreasing, and there's a couple of those intervals. And I'll highlight it here in yellow. If you look between negative infinity, right, and negative 2 on your graph, right, what is your graph doing? It's going down, right? It's decreasing in value. As x is getting larger, y is getting smaller. So as we were to write that decreasing interval, which we have actually 2 decreasing intervals. So let's go ahead and write those out. So we have a decreasing interval for all x values less than negative 2. So negative infinity, negative 2. So again, now I want to make note, so I'm writing these intervals, I'm always using a parentheses. I'm never going to use a bracket. Right? Bracket means we want to include the number. Well, with increasing, decreasing, constant intervals for that matter, we're always looking between the ends. We're never going to have brackets. Right? It's not doing anything at the end, but it's sitting there. So where is it decreasing in value? For those values less than -2, right? So -2, that's actually where our turn, that's where our turning point or relative min point will be defined, and we'll write that down a little bit. So all x values less than -2, it's decreasing. And of course, let's go back over here on the right side of this graph. I want you to look between 1 and positive infinity. So if you're looking along the x-axis, we always read our graphs left to right. So again, these are x values. So we're talking about another decreasing interval. So all x values greater than 1. So yeah, between 1 and infinity, what's the graph doing? It's going down. It's decreasing in value. All right, so that's the behavior of the graph. Now, there is no constant interval. It didn't ask for one. This graph is not staying the same as we move left to right, but that's something we do look for. So have a constant interval. It does not only increases or decreases throughout this graph. Moving on to the next part, let's find the set of x values where our function equals 0. Well, where our function equals 0, remember, these are our x-intercepts, right? Our zeros of our function. So where our graph crosses the x-axis. So where it equals 0, where it's sitting on the x-axis. So for example, right here at -3, right? So x equal -3 is a 0 of this function. X equal -1 is a 0 of this function. X equal 2 is a 0 of this function. So -3, -1, and 2, right, are the three locations of your x-intercepts. So zeros of that function. All right, next question asks, for where is g of x less than 0? So where are the values negative? Where are these outputs negative? Where is my graph taking place below the x-axis, right? That would be where my y-coordinates, my function values are negative. So if you look on this graph, right, in here, right, I'll write this down. G of x is less than 0, right, in here. These are all negative values. So if you look between what? Talking about the interval, we know g of x is less than 0 for all x values greater than -3 and less than -1, right? It's decreasing in value right here. Of course, all these are negative values. So above the x-axis, it'd be positive, right? Be positive outputs. Those are positive function values. But below the x-axis, we're on the negative side of the y-axis. If you look at those ordered pairs, those are all y-coordinates that are negative. All right, so where's our function negative? That's one interval. Now we also notice we have some negative values. I'll highlight it over here in blue. Where else do we see the graph take place below the x-axis? Well, all these values in here. Here's g of x less than 0. So all x values, so one more interval to write, all x values greater than 2, right? So from 2 to infinity, right, my graph is dealing with function values that are negative. All the outputs there are negative for all those x values greater than 2. Where is the function positive? So where is our graph taking place above the x-axis? So we're looking above the x-axis. So for example, in here, right, we're looking at positive function values, right? Right in here. So right here we got g of x being greater than 0, right? We also have g of x right here being greater than 0, anywhere in here. So again, these are our function values are positive. So for all x values, right, less than what, -3? So if x is less than -3, our graph's taking place on the positive side of the y-axis. Well, if we look at our graph between -1 and 2, right, all x values greater than -1 and less than 2. Now we do need parentheses. At -1 and 2, it equals 0. It's not asking me when it equals 0. Also, it's greater than 0. So make sure you're not including those. But that's where our function is dealing with positive function values. So you can see your graph, right? I'm highlighting it here in red. It's on the positive side of the y-axis. All right, moving on, it asks us now to find what we call our relative extrema. So our relative extrema are relative min or max points. So with that, those are our turning points in our graph. So I want you to look back at this point right here. This is a relative min point. What's happening at this point? The graph is changing behavior. It's changing from decrease to increase. It's a turning point in that graph. So that ordered pair, right, looking at that, right, we're at -2. So in the y-coordinate, looks like -4. So -2, -4 would be the point. Let's go ahead and mark the other turning point. I want you to look up here. There's one more turning point, one more relative extrema. And right here at this ordered pair, right, which looks like the ordered pair 1,8. At 1,8, we have what we call a relative max point, where our graph changes from increase to decrease, a turning point where it turns, right, in behavior. So at x equal -2, down here to finish this problem out, g of x has a relative, minimum, relative min value of -4. Right? What's the output at x equal -2? Got that value of -4. So yeah, -2, -4 is the min point. So it's expressing it there in words where we found it. And the other extrema, the max point at x equal to 1, we have a relative max value. Right? So again, relative to that part of the graph, that's a maximum point. All the other points to the left and right of are below that point, right? That's a relative max. Not the absolute max, not the highest point. That graph goes up forever. That left tail keeps climbing up. But relative to that part of the graph, we have a max value of 8, right? What's that y-coordinate? That's the value, the output. So at x equal 1, we have a max value of 8. So two relative extrema, right, with that one. All right? So that's, again, reviewing, analyzing the behavior, the characteristics of a graph. And we do the same thing in our next one, in example 4. Right? This next problem here, we got a graph of a function given. And it's asking us to analyze the graph. So let's go ahead and look at the graph of this function as we go through our characteristics. We'll talk about domain, range, and we'll do that in a little bit.